Hello everyone, good evening. Welcome to our online class. So in this class, we'll solve another problem on Green's theorem. So very important problem here. So it is a problem, verify Green's theorem for integral c e power minus x sin y dx plus e power minus x cos y dy, where c is the rectangle with vertices he gave here. Correct. So now we have to solve already 2-3 problems we solved on Green's theorem. Now we'll solve this problem also. So what he gave here, first of all, compare what we have to do, compare given with Green's theorem. What is Green's theorem? Circle integral c m dx plus n dy. So what we have to do, we have to compare given with the integral c m dx plus n dy is equal to double integral r dou n by dou x minus dou m by dou y into dx into dy. Correct? Dx into dy. This is our Green's theorem. Right? So now if I compare with given with Green's theorem, in place of m, how much we have? I get m is equal to e power minus x sin y, and n is equal to e power minus x cos y. E power minus x sin y, e power minus x cos y we get here. E power minus, okay, right. Now see here what we have to find. So first we'll solve right hand side part. So to solve right hand side part, so he gave, first we know the limits also. No, what he gave here, he gave rectangle with the vertices, right? So if I draw the rectangle here, okay, this is the rectangle. So first point is what? 0 comma 0 and pi comma 0. So pi comma pi by 2, then this is 0 comma pi by 2, right? So if I take this is 0, this is A, this is B, and this is C, right? Along OA, AB, BC, CO we have to find. Along AB, right? These are the points, right? Now here y is equal to 0, here x is equal to pi, here y is equal to pi by 2, and here x is equal to 0. This is our rectangle diagram, correct? So little bit like that. Now what to do now? So to first find out the limits here, we have to find RHS. So first partially differentiate with respect to x and y. So what I get here? Dou m by dou y. What is our dou m by dou y? E power minus x sin y differentiation is what? Cos y. So dou n by dou x, e power minus x differentiation is what? Minus e power minus x into cos y is as it is. Now limits here, what are the limits here? X is changing from 0 to pi. What are the limits here? X is changing from 0 to pi and y is changing from 0 to pi by 2. Y is changing from 0 to pi by 2, correct? X is changing from 0 to pi, y is changing from 0 to pi by 2. It's a lengthy problem, no? Let us see whether we'll solve. Now RHS, first right hand. See, whenever he's asking verify, you have to find left hand side and right hand side. If he's asking only apply Green's theorem, if you solve right hand side is enough. Now RHS, right hand side. What is right hand side? We have double integral r dou n by dou x minus dou m by dou y into dx into dy. Correct? You have to surface integral. It is 2 times you have to integrate. So here x is equal to 0 to pi and y is equal to 0 to pi by 2. Dou n by dou x is what? Minus e power minus x cos y minus dou m by dou y is what? E power minus x cos y into dx into dy. So dx into dy. So this is equal to what I get here. If I integrate here, so if I integrate here, so therefore this is equal, x is equal to 0 to pi, y is equal to 0 to pi by 2 minus 2 e power minus x cos y dx dy I get here, correct? Now integrate with respect to x and with respect to y. Minus 2 is a constant. If I integrate with respect to x, e power minus x integration is e power minus x by minus 1, 0 to pi. Then cos y integration is what? Sin y. Limits are 0 to pi by 2. So cos y limits is what? To sin y 0 to pi by 2. Now substitute upper limit here. So minus into minus plus. If I substitute upper limit, I get e power minus pi minus e power 0. And here sine 90 minus sine 0. Sine 90 is 1, sine 0 is 0. So what I get here, e power minus pi is how much ma? E power minus pi is as it is, and e power 0 is 1. So what I get here, 2 e power minus pi minus 1. This is our right hand side value RHS. This is our right hand side value RHS. Okay, it's not covered. Okay. Understand here? So first what we have to do, we have to compare given with the mdx plus ndy. So m value is this, n value is this ma. He gave rectangle, we plot the points. He gave the rectangle, we plot the points here. Correct. Then find dou m by dou y and dou n by dou x. Partially differentiate with respect to x and y. Dou m by dou y, dou n by dou x. Then right hand side I calculated. Limits are x is changing from 0 to pi. Y is 0 to pi by 2. So 0 to pi and y is 0 to pi by 2. Dou n by dou x I got minus e power minus x cos phi ma. Then dou m by dou y is what? Minus e power minus x cos phi. So minus 2 e power minus x cos phi dx dy. Minus 2 will stay outside. E power minus x integration. E power minus x by minus 1. Cos y integration sin y. Upper limit pi. Lower limit is what? 0. Minus into minus plus. Upper limit pi by 2. Lower limit is 0. Sin 91. Sin 90 is 1, sin 0 is 0. So 1 into this part I got RHS is equal 2 into e power minus pi into minus 1. Correct? Now what you have to find? We have to find LHS. What is LHS here? What LHS will give here? LHS is a now see here, LHS, what I get LHS ma? LHS will give you integral along OA plus integral along AB plus integral along BC plus integral along CO. Four directions you have to integrate and you have to find. So if you integrate these all 4 directions, what you have to get ma? You have to get 2 e power minus pi into minus 1. That we'll see whether we get or not. Okay. Yes. Now LHS is equal to integral c e power minus x sin y dx plus e power minus x cos y dy ma. So first we have to find along OA. First what we have to find? Along OA. So if I go from O to A, y is 0, then x is changing from y is 0 ma. So dy is 0. So x is changing from 0 to pi. X is changing from 0 to pi. So therefore integral OA, this is equal to integral OA. You can write it directly over here. This is equal integral x is equal to 0 to pi. Line integral, we have to change this part in terms of x or y. So we are changing in terms of x ma. So y is 0 e power minus x into sine 0 into dx. Dy is 0, anything 0 into anything is what? 0. Sine 0 is 0, so 0 into anything is what? 0. So along AO, how much we got? I got 0. Next along AB. Along AB, A to B. A to B mein x is equal constant, x is pi. So dx is equal to 0. Y is changing from 0 to pi by 2. What is the y value here? Y is changing from 0 to pi by 2. So therefore, this is equal along AB. Along AB, y is equal to 0 to pi by 2. Dx is 0, no? So this part is 0. Plus e power minus x is pi cos y into dy. Correct? So e power minus pi constant ma. Cos y integration sin y limits are 0 to pi by 2. So if I substitute upper limit pi by 2, sin 90 is 1. So sin 0 is 0. I get e power minus pi by, I get e power minus pi. Okay, e power minus pi. Next, third case, along BC. So if I take along BC, B to C, y is pi by 2, dy is equal to 0, x is changing from pi to 0 ma. Coming back, no, x is changing from pi to 0, right? So pi to 0. So therefore this is equal to integral x is equal to pi to 0, y is equal to pi by 2. If I substitute here y is equal to pi by 2, e power minus x sin pi by 2 into dx plus dy is 0. So this part is 0 ma. E power minus x integration e power minus x by minus y. Sin 90 is how much ma? 1. So limits are pi to 0. So substitute upper limit here. E power 0 is 1. So I get here minus 1. Minus of minus plus e power minus pi. Minus of minus plus, I get e power minus pi. Okay. Okay, it's covered or not? 1 second. Right. Right. E power minus pi. Next, last case, ma. It's a very lengthy problem. That is the problem over here. Next, last case, along along CO, x is equal to 0, dx is equal to 0, y is changing from pi by 2 to 0. Y is changing from pi by 2. The diagram also not visible, right? Okay, y is equal to pi by 2 to 0, ma, right? Now, how to solve here? If y is equal to pi by 2, so therefore this is equal to y is equal to pi by 2 to 0. X is 0, this full part, first part is 0, I get here. First part is 0. Then e power x is 0, ma, e power 0 into cos y into dy. E power 0 is 1, cos y is sin y. Limits are pi by 2 to 0. Upper limit 0, 0, sin 91. So I got minus 1. How much I got, ma? I got minus 1. Now, what we have to do? We have to add these all 4 cases. We have to add along OA, along OA, along AB, along OA, along AB, and along BC, along CO. These are 4 cases you have to add. Right. So if I add those all things, LHS is equal to integral OA plus integral AB plus integral BC plus integral CO. Ma. OA value is how much I got? I got 0. Then AB's value, how much I got? E power minus pi. Then BC, along BC, how much I got? Minus 1 plus e power minus pi. Along CO, how much I got? Minus 1 I got, ma. So minus 1 minus 2. E power minus pi, 2 e power minus pi. Take out 2 common. So I get 2 into e power minus pi minus 1. So RHS is also 2 into e power minus pi minus 1. LHS is also 2 into e power minus pi minus 1. LHS is equal to RHS. Green's theorem is verified. So like that, you have to solve very, very important problem, Green's theorem. So already we did the 2 or 3 problems. So this one also one problem is there. Just to solve this problem, first what we have to do? First, we have to compare with the Green's theorem. We have to compare with the Green's theorem, then find the value of m, n, then dou m by dou y, dou n by dou x, solve right hand side, then left hand side. If you want to solve first left hand side, you can solve it left hand side. If you want to solve first right hand side, you can solve it right hand side. But at the end, what we have to show? LHS is equal to RHS, we have to prove. Okay, that's it.